Today we're at the production site for Appropriate Energy Saving Technologies, AEST, in Soroti, Uganda. I'm Dan, and I'm trained as an engineer, and I do research to help people design processes that make cooking fuel. I'm an engineer at D-Lab at the Massachusetts Institute of Technology. We work on technologies for people who are living in developing countries. D-Lab is working with several entrepreneurs in Uganda. One of those entrepreneurs is Betty Ikolani. Betty has a company in Uganda that makes clean-burning cook stoves and clean-burning fuel made from farm waste.
Our mission is to increase access to clean cooking solutions in Uganda.
D-Lab has worked with Betty on ways to efficiently convert farm waste into char, and then clever ways to turn the char into briquettes at very large scales, so she can sell this fuel to a lot of people in her community.
We came into contact with Dan Sweeney, who has been so supportive to us. He comes to Uganda. He has helped us to work on our machines, designing an extruder, which has helped us increase our production level.
So how is the charcoal made? It's a lot like the process that forms fossil fuels. Decomposed plant and animal material buried under layers of rock has been heated under pressure over millions of years to form gas and crude oil. Charcoal can be made using a similar process in a very short amount of time from renewable farm waste that is produced after each harvest on farms all over the world. And charcoal is a familiar material that people are comfortable cooking with. Today we're here at the infamous place where D-Lab gathers every fall semester to make charcoal. When you make wood charcoal, you cut down a tree. The problem is there's not a lot of trees left, right? So D-Lab helped to establish a method where you can take farm waste and turn that into charcoal briquettes. All right, do we have a volunteer to light? Woo! Nice. Oh, there it goes. Yeah. All that stuff that's coming off, all those oils and what we call volatiles, we've now produced a big flame, which is burning those volatiles. The drum limits the amount of air that's going in, so it kind of smolders and burns down to charcoal rather than just burning all the way down to ash. And now we're almost quenched, we call it, right? But just to make sure that we cut off all air, we'll just seal around the bottom of this and also around the top. Cool, that looks good. We'll take these stalks, which have been carbonized, and we'll grind them into a powder. Then you take the powder and mix it with a sticky, starchy binder, kind of like glue. You mix those together, nice, and press them into small briquettes, which we then set out to dry under the sun. So today we saw the D-Lab students having fun, but also learning about how this is done. On the other side of the world, where we work in Africa and elsewhere, this is an everyday routine for people. The reason that engineering is important in this process is if we do a good job of designing our tools, we can, one, make something that's very efficient, and two, make something that's understandable and usable to a lot of people.
But this is smooth. It's by hand?
There's a fulfilling part of it, right? There's that. There's a lot of really interesting challenges too, right? As an engineer, you can go to Uganda and see a lot of places that an engineer could help out and benefit those communities. So if you're someone who likes to tinker and build things, you might be interested in engineering. You'll find that you can take those things that are fun for you to do and put them to use and help other people at the same time and have fun while you're doing it.